All right. Sorry. It's time. When we factor, first thing we always check for, GCF. A GCF has to go into all of the terms that we see. Does the first problem have a GCF? Why not? I thought 4 went into 12.
Oh, yeah, 4. It does go into 9. No, 9.
It doesn't go into 9. Yes. All right, so no GCF here, which means we're going to do what second? Yep. We're going to make our area model. And do our X. What information do I want in the upper left box? A. What is our A term? 4x squared. What do I want in the lower right? C. And our C is 9. So then I come over to the box and do 9 and 12, right? Why not? It's A times C. Don't just grab that last number. We do A times C. So what numbers am I multiplying together? 4 and 9, which is 36. And it has to add to give me my B value, which is 12. 6 and 6. So I have 6x and 6x. Now we're going to pull the greatest common factors out of all of the rows and all of the columns. Across the top, 4x squared and 6x, what goes into both of those? 2. What else? X. They both have an X. Across the bottom, I know a lot of us have gotten in the habit of taking whatever this is right here and pulling that out. So do I have a 6 right here? No, why not? 6 doesn't go into 9. So what does go into 6 and 9? 3. Positive or negative 3? Positive. So 2x plus 3. And then I'm going to do the columns. 4x squared and 6x. 4x squared and 6x. What goes into it? 2x and 6 and 9. 3 again. Positive 3, negative 3? Positive. So in its factored form, I have 2x plus 3 and 2x plus 3. So I want to make sure that we understand something before we go to the second example, before we go on to our lesson for today. These are the factors of this. If something is a factor, that means if I multiply those factors together, I get that. If I multiply 2x plus 3 with another 2x plus 3, this up here will be the result of multiplying this piece and this piece together. Just like I can say that 3 and 4 are factors of 12, because if I multiply 3 and 4 together, I get 12. So far, so good? All right. Second one. First thing I always check for. It is a difference of perfect squares. I still have to check for a GCF. You still have to check it for a GCF. No. I know some people approach this with an area model, and you technically can. It is a difference of perfect squares. I want to show you real quick with the area model why I don't like that for some of our difference of perfect squares questions. So 9x squared, negative 25. When I do the x, I have to multiply a and c together. What is 9 times negative 25? What is 9 times negative 25? Negative 225. What would go on the bottom of this x? 0. So if I was going to solve this using an area model like I did the first one, I've got to think up two numbers that multiply to negative 225 and add to 0. This is why I showed you guys the other way of factoring a difference of perfect squares. All right, so if I use the shortcut method that I taught you guys for a difference of perfect squares, how many sets of parentheses, how many factors are we going to have? 2. How do you know that from looking at it? Has an x squared. The biggest exponent is a 2. That tells me I've got 2 factors. We are multiplying these factors together. What would I multiply by itself to get 9x squared? 3x. I can't put 3x and 3x inside the same factor because that's not being multiplied. I have to put the 3x and the 3x in each factor because those pieces are being multiplied. Negative 25. These numbers have to be the same, but I want it to multiply to negative 25. Yep, 5 and negative 5. The number itself has to be the same, 5 and 5. One of them has to be positive, one of them has to be negative. So positive 5 and negative 5. There's my factored form here. If you were doing this with an area model, technically you can. Multiplies to negative 225, adds to 0. That would be 15 and negative 15. So we could have done it like this, but it would take us a while to come up with those numbers. What goes into 9 and 15?
3.
3 goes into both of them. So across the top, I would have a 3x. What goes into 15 and 25? 5. Would this be a positive or a negative 5 over here? Negative, because the 15 is negative. Notice, that's exactly what I have right there. 9x squared, negative 15x. What goes into both of those? 3. So I would have a 3x. Positive 15 and negative 25. Positive 5. Notice that I get the exact same 2 factors if I do it using the area model method as I do using the shortcut. For some of your difference of squares, it's just as fast to do it that way. When these numbers get really big, I would always use the shortcut there. Do you guys have any questions for me on the bell work? Okay. You just needed a minute. What day of the week is it? Friday. What are you guys going to do before you leave the room? Turn your bell work in. Yes, you may. All right. Please do not put your bell work in your folder because you're going to turn that in before you leave. Do pull out your notes. We are on the very back page, page 8. What did we do yesterday in the notes? We added rational expressions. Today we are going to subtract rational expressions. It's pretty much exactly the same process, but I have to be careful with subtraction signs. So I can subtract these only if they have common denominators. Just like when I'm adding, I have to have common denominators. There we go.
This is page 8.
Page 8, very back side. Last page in the packet.
I missed the whole thing.
All right. The way we find our common denominators, I need to know what factors they have in common already. If they have it in common already, I don't need to multiply by it because they share that piece. I only multiply by what they have that's different. So, looking at example 9, the first example on the back side. Do 9y and 6z have any factors in common? Is there anything that goes into both of them? 3. If I write 9 down in its factored form, that would be 3 times y, right? How can I write 6z in its factored form? 3 times 2 times z. I always want to factor my denominators, whether it's monomials like this or polynomials like we did on the bell work. I start off by factoring the denominators and I identify what is the same about them. And you said they have what factor in common? 3. If they already have it in common, I don't need to multiply by it. What does the second fraction have in its denominator that the first one does not? What does the second denominator have? It has a 2 and a z. So I'm going to multiply this first fraction, top and bottom, by 2z. Bring my subtraction down. 7y, 6z. What does the first denominator have that the second one doesn't? 3 and y. So I'm going to multiply this one by 3 and y. How do we multiply fractions together? Straight across. So we're going to multiply the tops together. We're going to multiply the bottoms together. What do I get when I multiply 2z and 2x? 4xz. So that's when I multiplied the tops together. What about when I multiply 2z and 9y? 18yz. Bring down my subtraction. And now I have to multiply this second one together. 7y times 3y. 21y squared. And what about 6z and 3y? 18, I didn't hear the rest of it. yz. Do we have the same denominator on both of them? Yes. So if I have the same denominator on each of these, then I'm going to be able to subtract those numerators. So my denominator for my final answer is 18yz. My first numerator is 4xz. I'm going to bring down that subtraction. 21y squared. Can I combine any terms in my numerator? Are they like terms that will allow me to combine them? No. Then that's my final answer. What would it look like if they were like terms? Like, how would I know that they are like terms? Has the same variables and the same exponents. So if I have an x and an x squared, I can't combine those. But if I had a 4xz and a 21xz, I could combine those pieces together. All right. Next to last, example 10. I want to know if those denominators have any factors in common.
Yes.
What factors do they have in common? Remember, factors are things that we multiply together. So negative 15 times what would give me x squared plus 2x minus 15? Nothing. Then 15 and negative 15 are not factors of this. How would I figure out what the factors are? Factor it, yes. We have to factor this. That's how we find what multiplies together to give us that denominator. So x squared plus 2x minus 15. We're going to factor this. First thing I always look for when I'm factoring. GCF. Do we have a GCF here? No GCF. Remember, it's got to go into all the pieces. All right, so that means it's time for area model and x. What goes in the upper left? X squared. What goes in the lower right? Negative 15. Then I come over to the x. What goes up on top? Negative 15. I multiply a and c together, so I multiply 1 and negative 15 together. It needs to multiply to give me negative 15, but add to give me 2. I heard 5 and negative 3. So 5x and negative 3x. Greatest common factors for all my rows and columns. What can I take out of x squared and 5x? What can I take out of x squared and 5x? X. What about negative 3x and negative 15? Negative 3. How do we know it's negative? Because it's touching a negative right here. So x minus 3 is one of the factors. This times something else will give me that denominator. My columns are going to give me that other factor. X squared and negative 3x. X. 5x and negative 15. 5. Positive or negative 5? Why is it a positive 5? Because the 5 is positive. If I multiply x minus 3 and x plus 5 together, I get that original denominator. So I'm going to rewrite this first fraction. 2x plus 1 over x minus 3 times x plus 5. I'm going to bring that subtraction down. I need to factor this also. What's the first thing we always look for when we factor? GCF. Does this have a GCF? What is it? 5. So I'm going to take the 5 out. I can't throw it away because that's one of the things that gets multiplied here. X minus 3. If I distribute, multiply the x. Oh, lovely. If I distribute the 5 to the x and to the minus 3, I get 5x minus 15. If I multiply those pieces together, I get that original denominator. All right, so I have 7 over 5 times x minus 3. So now I'm going to ask again whether these denominators have any factors in common. Is there anything that goes into both of them? Yes. What goes into both of them? What do they share? X minus 3. They have this in common already. What does the second denominator have that the first one doesn't? 5. A 5. So I'm going to multiply top and bottom by 5. What does the first denominator have that the second one doesn't? X plus 5. So I have to multiply top and bottom by x plus 5. When you look right here, because I'm going to multiply these together, is that exactly the same as what I have right here? Do they have all the same pieces now? Yes. This right here is exactly the same as this over here now. All right. Let's simplify each of these fractions. I have 5, x minus 3, x plus 5. I'm multiplying this together, right? Guys, stay with me, please. That means I have to multiply 5 with this entire numerator. 10x plus 5, yes. Since this numerator had 2 pieces, I have to distribute to both of those pieces. 10x plus 5. I'm going to bring this subtraction down. This denominator is 5 times x minus 3 times x plus 5. And what do I have to do here? Up on the top, yeah. Yep. I have to distribute the 7 to both of these pieces. So 7x plus 35. Do I have a common denominator? Yes. That's going to be the denominator of my final answer. One of the things I want to point out real quick. When you write these factors down, if they are in a different order, that does not matter. Because when I multiply things together in my calculator, the order that I do that in does not affect the answer. All right.
So you can actually like subtract that and have
Yeah. We got to be careful. All right, I'm going to write down my denominator, 5 and x minus 3, x plus 5 on the bottom. My first numerator, I'm just going to recopy, 10x plus 5. What am I doing between these fractions? Subtracting. I am subtracting everything that comes after the minus sign. So I have to distribute this subtraction to both pieces. I'm not just subtracting the 7x, I'm also subtracting the 35. So negative 7x minus 35. Are there any like terms that I can combine together? Which pieces are like terms? 10x and negative 7x. When I combine those, that gives me what? 3x. Any other like terms? Yep. Negative 35 and positive 5. When I combine those, I get negative 30 all over my common denominator of 5 times x minus 3 times x plus 5. Can I simplify that any more? Nope. That is fully simplified. That's my final answer. Last example problem, and then we are done for the week. What is going on in this last problem?
it's both of the plus and minus.
I've got plus and minus here. And then why? Because
Tangent and cosine over sine.
cotangent of 1/2 isn't on the unit circle.
Oh,
So you have to use Pythagorean theorem if it's not on the unit circle. And then secant is y over, or sorry, not y, r over x. So we did r over x, which was All right, we've got addition and subtraction going on here. Do my denominators have any common factors? Is there anything that's the same that goes into all of them?
All three of them?
X times what would give me x squared minus y squared? Remember, if I'm going to write this down as a factor, x times what gives me all of that? X times x gives me x squared, but it has to give me all of this. It has to give me the whole denominator. X times y, x times y. What do we call this special situation? Yes, this is a difference of perfect squares. How many factors do I get when it's a difference of perfect squares? How many factors do we get for a difference of perfect squares? 2. What multiplied by itself would give me x squared? X and x. Each factor has to have an x in it. One has to be plus y, the other has to be minus y, because that's the only way I can multiply it and get a negative y squared. All right, x squared plus y squared over my newfound common denominator, or not common denominator, sorry, my newfound factor denominator of x plus y times x minus y plus y over x plus y minus x over x minus y. Do my first two denominators have anything in common? The first two. They have x plus y, right? What would I have to multiply this middle fraction by so that they could have the exact same denominator? X minus y, top and bottom. What about the last fraction? What would I need to do there so it could have the exact same denominator? Multiply it top and bottom by x plus y. All right, let's do that. So I have x squared plus y squared over x plus y times x minus y plus, what do I need to do in this numerator here? Multiply. What am I multiplying? Yep, multiply y and x. Yes, so it's going to be xy minus y squared over x plus y, x minus y. Minus, what do I have to do here? Multiply. So what am I going to get when I multiply? When I distribute by multiplying, what am I going to get? X squared plus xy. Do I have common denominators on all three of these? Yes. X plus y, x minus y. All right, so I have x squared plus y squared, my first numerator. When I've got addition, I don't need to worry about changing anything. I'm going to add xy, and I'm going to add a negative y squared, which is the same thing as minus. So plus xy minus y squared. What do I have to watch out for with this last fraction, this last numerator? Back here. It's right after a minus, right? So I'm subtracting x squared, and I'm subtracting xy. There's a really long numerator there. What do you see that cancels? The xy. I have a positive xy here, and I have a negative xy here. All right, so that would leave me with x squared plus y squared minus y squared minus x squared over x plus y, x minus y. I'm just rewriting what we've got. If you do it all at the same time, that's fine. What was the next thing you told me would cancel? The x squareds are going to cancel because I have a positive x squared minus x squared. Yeah. Whoop. Hold on just 1 second. I'm going to scoot this over so that I've got room. I just want to look at this a piece at a time. Y squared minus y squared over x plus y times x minus y. You said the y squareds cancel. If I cancel by subtraction, like let's pretend this was numbers. If this was 5 minus 5, what is 5 minus 5?
0.
So what is y squared minus y squared?
0.
0. So I've got 0 over x plus y, x minus y. Does that simplify? What is 0 divided by 2?
0.
What is 0 divided by 100?
0.
What is 0 divided by x?
0.
What is 0 divided by x plus y times x minus y? 0. My final answer is 0. All that just to get 0. All right, so full disclosure, I've only ever seen everything cancel out like this one other time. Most of the time when we're doing our adding and subtracting with rational expressions, not every piece will cancel out. So please be careful about that. Yes, sir.
If you leave it like in like x squared, y squared minus y squared over x plus y times 9, x minus y, is that okay? If you leave it like that?
If you left it like this,
Like that or like any one?
you've got to you have to combine all your like terms together. It's not considered done unless you combine all your like terms together. All right, big takeaway for today. Very, 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 very important. When we are adding, nothing changes about our numerator. No operations change there. But when we are subtracting, you have to distribute that negative. Adding, nothing changes. Subtraction, all your signs will change. Only what comes after the minus sign. When is your quest? Next Wednesday. What's due between now and then? Bell work and homework 3. Homework 3 is due on Monday. I'm going to go ahead and get this into your hands. This is the review for the quest next week. All right? So this way you'll have it over the weekend. You want to focus on getting the homework done, but definitely make sure that you are preparing for the quest on Wednesday. It's the length of a quiz, but it's going to go in the test category. It's worth half of a test.
right.
Do you guys have any questions for me? Cool.